Picture this. Somewhere in the depths of space, there exists a star so monstrously large that if you placed it at the center of our solar system, it would swallow Mercury, Venus, Earth, Mars, and stretch all the way past Jupiter's orbit. This cosmic giant is so unimaginably massive that our sun would look like a grain of sand next to a basketball in comparison. But here's where things get absolutely terrifying. This stellar behemoth isn't just sitting peacefully in space, it's dying a violent, chaotic death that's been unfolding for decades, and we've been watching it happen in real time. Scientists have recently captured the first ever close-up image of this monster star, and what they discovered has fundamentally changed our understanding of how the universe's most extreme objects meet their end. This is WOH G64, and it's about to teach us some truly disturbing lessons about the cosmos we live in. Now, before we dive into the nightmare that is this star's death throes, let me blow your mind with just how absurdly large we're talking here. When astronomers first discovered WOH G64 back in the 1970s, they knew they had found something extraordinary. But it wasn't until decades later that they realized they were staring at what might be the single largest star ever discovered in the universe. We're talking about a star that's roughly 800 times the radius of our sun. To put that in perspective, light takes about 4.5 seconds to travel from the sun to Earth. If WOH G64 were in our sun's place, its surface would be so far out that light would take over 20 minutes just to travel from one side of the star to the other. The sheer scale is so mind-bending that our brains literally cannot process it. But size is just the beginning of this star's terrifying story. WOH G64 is what astronomers call a red supergiant, and these cosmic monsters are among the most violent and unstable objects in the entire universe. They're stars that have lived fast and hard, burning through their nuclear fuel at rates that would make our sun look like a dying candle. While our sun has been steadily burning for 4.5 billion years and will continue for another 5 billion, WOH G64 has already burned through most of its fuel in just a few million years. And here's where the horror really begins. When a star this massive starts running out of fuel, it doesn't just quietly fade away like our sun will. Instead, it begins a process so violent and chaotic that it defies comprehension. The star's core starts collapsing under its own immense gravity, while simultaneously trying to fuse heavier and heavier elements. Iron, silicon, carbon. The star desperately tries to keep the nuclear fires burning, but it's fighting a losing battle against the fundamental forces of physics. What makes WOH G64 particularly terrifying is that it's not dying alone. Recent observations have revealed that this monster star is actually part of a binary system, locked in a cosmic dance with a smaller companion star. This discovery has completely rewritten our understanding of how the largest stars in the universe evolve and die. The gravitational interaction between these two stars is literally tearing WOH G64 apart from the outside, while its core collapses from within. But wait, it gets worse. In 2024, astronomers using the European Southern Observatory's Very Large Telescope achieved something that was previously thought impossible. They managed to capture the first detailed image of a dying star outside our own galaxy. What they saw around WOH G64 was so unexpected and disturbing that it forced them to completely reconsider everything they thought they knew about stellar death. The star is surrounded by what can only be described as a cocoon of death. This isn't just any ordinary stellar wind or gas cloud. WOH G64 has expelled between 3 and 9 times the mass of our entire sun into a dust envelope that stretches for nearly a light year in diameter. To put that in perspective, this envelope of expelled material is so large that it would take light an entire year to cross from one side to the other. And here's the truly disturbing part. This cocoon isn't spherical like astronomers expected. Instead, it's egg-shaped, stretched and distorted in ways that suggest something catastrophic is happening to the star's internal structure. The shape of this death shroud indicates that WOH G64 is ejecting material in violent, asymmetric bursts rather than the steady, predictable winds that most stars produce. The implications of this discovery are absolutely chilling. When astronomers compared recent observations with older data, they discovered that WOH G64 has been dimming significantly over the past decade. This isn't just a normal fluctuation. It's a sign that the star is entering what scientists call the superwind phase, the final act before a supernova explosion. But here's where the story takes an even more disturbing turn. Well, G64 isn't just any red supergiant anymore. Recent spectroscopic analysis has revealed that the star has undergone a dramatic transformation, evolving from a red supergiant into something even rarer and more unstable, a yellow hypergiant. There are only about 20 of these objects known in our entire galaxy, and WOH G64 has just become the first one ever discovered outside the Milky Way. This transformation is so rare and violent that astronomers are still struggling to understand what causes it. The leading theory is that the companion star has been literally stripping away WOH G64's outer layers through gravitational interactions, causing the exposed inner regions to heat up and change color from red to yellow. But this process has made the star even more unstable and unpredictable than before. Yellow hypergiants are among the most dangerous objects in the universe. They're massive stars caught in a transitional phase, neither red supergiants nor the blue giants they might become. They're essentially stellar time bombs, capable of exploding with virtually no warning. The fact that WOH G64 has transformed into one of these cosmic monsters means that its final explosion could happen at any moment, or it might still be thousands of years away. The uncertainty is what makes it so terrifying. Adding to the horror is the realization of just how much energy this dying star is pumping out. Our G64 shines with the brightness of almost 300,000 suns. The amount of energy it produces every second is so vast that if you could somehow capture just 1 second's worth of its output, it would power human civilization for millions of years. And all of that energy is being produced by nuclear reactions happening in a core that's smaller than the Earth, surrounded by layers of gas that extend farther than Jupiter's orbit. The stellar winds coming off WOH G64 are equally mind-boggling. The star is losing mass at a rate that would make the most powerful hurricanes on Earth look like gentle breezes. Every year, WOH G64 expels several hundred times the mass of our entire planet into space. These winds carry temperatures of thousands of degrees and travel at speeds of hundreds of kilometers per second, creating a constant stream of death radiating outward from the star. But perhaps the most terrifying aspect of WOH G64 is what happens next. This star is a ticking time bomb on a cosmic scale, and when it finally explodes as a supernova, the energy release will be so intense that it will briefly outshine the entire Large Magellanic Cloud galaxy that contains it. The explosion will be visible from Earth, appearing as a new star in our night sky that could be bright enough to see during the day. The supernova will release more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. The explosion will accelerate debris to a significant fraction of the speed of light, creating shockwaves that will trigger the formation of new stars throughout the galaxy. Elements forged in WOH G64's core, carbon, oxygen, silicon, iron, will be scattered across space, eventually becoming the building blocks for new worlds and potentially new forms of life. But the most chilling part of this cosmic drama is the timing. Astronomers believe WOH G64 could explode as a supernova within the next 1,000 years. In cosmic terms, that's practically tomorrow. The star could have already exploded, and we just haven't seen the light yet because it takes 160,000 years for light to travel from the Large Magellanic Cloud to Earth. This means that somewhere in the depths of space, one of the largest stars ever discovered, is in its final death throes, surrounded by a cocoon of its own expelled material, slowly building toward one of the most violent explosions the universe can produce. And we're watching it happen, frame by frame, like a cosmic horror movie playing out across astronomical timescales. The study of WOH G64 has opened up entirely new questions about how the most massive stars in the universe live and die. Every observation reveals new mysteries, new complexities that challenge our understanding of stellar physics. This star has become a laboratory for studying the most extreme processes in nature, a window into the violent mechanisms that have shaped our universe since the first stars ignited billions of years ago. What makes this discovery even more disturbing is how it's forcing scientists to completely rewrite the textbooks on stellar evolution. For decades, astronomers thought they understood how massive stars die. The process was supposed to be relatively predictable. A star burns through its fuel, the core collapses, and boom, supernova, clean, simple, textbook physics. But WOH G64 is throwing all of that conventional wisdom straight out the window. This star is behaving in ways that shouldn't be possible according to our current models. The transformation from red supergiant to yellow hypergiant, the asymmetric dust cocoon, the dramatic dimming. None of this fits the neat categories that scientists have spent generations developing. And here's what's truly keeping astronomers awake at night. If we're this wrong about WOH G64, what else don't we understand about the universe's most extreme objects? This single star has revealed that our knowledge of stellar death is embarrassingly incomplete. We're essentially cosmic toddlers, trying to understand the workings of a nuclear reactor. The implications go far beyond just this one star. Throughout the universe, there are countless other red supergiants and hypergiants that we assumed we understood. But if WOH G64 can undergo such dramatic transformations, what's happening to all those other stellar monsters lurking in distant galaxies? Are they also ticking time bombs that could explode without warning? What's particularly unnerving is the role that WOH G64's companion star plays in this cosmic horror story. This smaller star isn't just an innocent bystander. It's actively participating in the destruction of its giant partner. The gravitational forces between these two objects are so intense that they're literally reshaping both stars from the inside out. Think about it this way. Imagine two dancers locked in an embrace, but instead of gracefully waltzing across the floor, one partner is systematically tearing pieces off the other. That's what's happening in this binary system. The smaller star's gravity is pulling streams of material away from WOH G64's surface, creating spiral patterns of gas and dust that stretch across interstellar space. But here's where it gets really twisted. As the companion star strips away WOH G64's outer layers, it's not just stealing material, it's also changing the fundamental physics inside the giant star. The mass loss is causing the star's internal structure to readjust, potentially triggering new nuclear reactions, or altering the balance between gravity and radiation pressure. This process has turned WOH G64 into something that defies easy classification. It's no longer a typical red supergiant, but it's not quite a yellow hypergiant either. It's become a stellar chimera, displaying characteristics of multiple types of stars simultaneously. The spectroscopic data shows features that shouldn't coexist in a single object, creating a puzzle that's driving astrophysicists to the brink of madness. The dust cocoon surrounding WOH G64 tells its own terrifying story. When astronomers first detected this envelope back in the 1980s, they assumed it was just a normal stellar wind made visible. But the new high-resolution images reveal something far more sinister. The cocoon isn't just dust and gas, it's a graveyard of the star's former self. Every particle in that envelope was once part of WOH G64's outer layers. Carbon atoms forged in the star's core, silicon created through nuclear fusion, oxygen born in the stellar furnace. All of it has been violently expelled into space. The cocoon is literally made of star guts, the scattered remains of a dying giant. And the shape of this cocoon is what's really disturbing scientists. Computer models predicted that dying stars should create roughly spherical shells of expelled material. But WOH G64's cocoon is distinctly egg-shaped, with clear asymmetries that suggest the ejection process was far from uniform. Something inside the star was creating preferential directions for material to escape, possibly indicating chaotic convection patterns or magnetic field interactions that we don't fully understand. The temperature structure within this cocoon is equally bizarre. Different regions show vastly different temperatures, creating a patchwork of hot and cold zones that shouldn't exist if the material was expelled uniformly. Some areas are glowing at thousands of degrees, while others are barely above the temperature of interstellar space. This suggests that the ejection process was episodic, with violent outbursts separated by periods of relative calm. But perhaps the most chilling discovery about WOH G64's cocoon is how quickly it's changing. Observations taken just a few years apart show dramatic differences in structure and brightness. In cosmic terms, this is happening at lightning speed. Stars are supposed to evolve over millions of years, not decades. The fact that we can see WOH G64 changing in real time means that whatever's happening inside this stellar monster is accelerating towards some kind of catastrophic endpoint. The massa emissions coming from WOH G64 add another layer of cosmic horror to this story. Masses are like natural laser beams created when specific molecules in space get excited by radiation. The fact that WOH G64 is producing intense massa emissions in multiple molecular species, water, silicon monoxide, and hydroxyl radicals, indicates that the chemistry in its immediate vicinity is absolutely chaotic. These massa beams are so intense that they can be detected from 160,000 light-years away. They're essentially cosmic lighthouses, broadcasting the star's death throes across the galaxy. But unlike regular lighthouses, these beams carry information about temperatures, densities, and velocities that would instantly vaporize any material object. The variability patterns of WOH G64 have also become increasingly erratic over the past decade. Red supergiants typically show semi-regular brightness variations as they pulsate like cosmic hearts. But WOH G64's pulsations have become completely irregular, suggesting that the star has lost any semblance of internal stability. It's essentially having stellar heart arrhythmia on a scale that dwarfs entire solar systems. This irregular variability is particularly ominous because it's often star explodes. When the delicate balance between gravity and radiation pressure, finally the last sign astronomers see before a massive breaks down completely, the star's brightness becomes completely unpredictable. Every flicker could be the prelude to the final explosion. What makes WOH G64 even more terrifying is its location in the Large Magellanic Cloud. This satellite galaxy of the Milky Way is close enough for us to study in detail, but far enough away that we're seeing the star as it was 160,000 years ago. For all we know, WOH G64 could have already exploded, and the light from that explosion is racing toward us at this very moment. The thought that we could wake up tomorrow to find a new star blazing in our night sky is both thrilling and deeply unsettling. A supernova from new star that could rival Venus in brightness, serving as a constant WOH G64, would be visible to the naked eye for months, possibly years. It would appear as a brilliant reminder of the violent processes that govern the universe. But the really disturbing part is what happens after the explosion. When WOH G64 finally detonates, it won't just disappear in a blaze of glory. The explosion will create a shockwave that travels through space at thousands of kilometers per second, heating up the surrounding interstellar medium and triggering a cascade of stellar formation throughout the Large Magellanic Cloud. The heavy elements created in WOH G64's core will be scattered across hundreds of light-years of space, seeding future generations of stars and planets with the materials necessary for rocky worlds and potentially life itself. In a very real sense, WOH G64's death will give birth to countless new worlds, making this cosmic horror story also a tale of regeneration and hope. Yet even as we contemplate the eventual explosion of WOH G64, new mysteries continue to emerge from ongoing observations. The star's spectrum shows emission lines that shouldn't exist in a normal red supergiant or yellow hypergiant. These mysterious features suggest the presence of highly ionized gases at temperatures that seem impossible given the star's surface temperature. Some researchers have proposed that WOH G64 might be experiencing internal shock waves that are heating small pockets of material to millions of degrees. Others suggest that the star's magnetic field might be creating localized acceleration zones where particles reach relativistic speeds. But honestly, nobody really knows what's causing these anomalous spectral features. This uncertainty is perhaps the most terrifying aspect of WOH G64. Despite decades of study and the most advanced astronomical instruments ever built, this star continues to surprise and confound scientists. Every new observation reveals additional layers of complexity that push the boundaries of our understanding. The most recent breakthrough in WOH G64 research has revealed something that's genuinely keeping astrophysicists awake at night. Using the Very Large Telescope Interferometer, scientists have been able to peer through that massive dust cocoon and actually see what's happening to the star itself. What they discovered is so fundamentally disturbing that it's forcing us to question everything we thought we knew about how matter behaves under extreme conditions. The star's surface isn't smooth like you might expect. Instead, it's a churning, boiling nightmare of convective cells that are each larger than our entire solar system. Imagine taking the most violent thunderstorm you've ever witnessed and scaling it up until each lightning bolt could incinerate entire planets. That's what's happening across every square inch of WOH G64's surface, 24 hours a day, 7 days a week. These convective cells are moving at speeds that would make a Category 5 hurricane look like a gentle summer breeze. Material from deep inside the star is being violently hurled to the surface at velocities exceeding 100 kilometers per second. When this superheated plasma reaches the surface, it explodes outward with the force of billions of nuclear weapons detonating simultaneously. But here's what's really twisted about this process. The material being expelled isn't just random hydrogen and helium. Deep spectroscopic analysis has revealed that WOH G64 is literally vomiting up the products of nuclear fusion from its core. Carbon, nitrogen, oxygen, silicon, elements that took millions of years to create through stellar nucleosynthesis, are being violently ejected into space before they can be processed into even heavier elements. This means that WOH G64 is essentially wasting the very fuel it needs to stay alive. It's like watching someone with hypothermia throw their last pieces of firewood out into a blizzard. The star is destroying itself from the inside out, and there's absolutely nothing that can stop this process once it begins. The temperature gradients across WOH G64's surface are equally mind-bending. While most of the star glows at around 3,000 degrees Celsius, certain regions spike to temperatures exceeding 10,000 degrees. These hotspots appear and disappear seemingly at random, creating a patchwork of thermal chaos that defies every computer model astronomers have built. What's causing these temperature spikes remains a complete mystery. Some scientists think they might be caused by magnetic field reconnection events, essentially stellar earthquakes that release massive amounts of energy in microseconds. Others believe they could be the result of exotic nuclear reactions happening in the star's outer layers, processes that we've never observed before. and don't fully understand. The magnetic field itself around WOH G64 is unlike anything else in the known universe. Most stars have relatively simple dipole magnetic fields, like a giant bar magnet floating in space. But WOH G64's magnetic field is so complex and chaotic that it resembles a three-dimensional spiderweb made of pure energy. This field is constantly shifting, twisting, and reconnecting in ways that generate bursts of radiation powerful enough to sterilize entire planetary systems. These magnetic field interactions are also responsible for accelerating particles to nearly the speed of light. WOH G64 is essentially a massive particle accelerator, creating cosmic rays with energies that rival the most powerful machines humans have ever built. These high-energy particles stream outward from the star in all directions, carrying enough energy to completely alter the chemistry of any material they encounter. But perhaps the most disturbing aspect of WOH G64's current state is how it's affecting the fabric of space-time itself. Einstein's theory of general relativity predicts that extremely massive, rapidly changing objects should create ripples in space-time called gravitational waves. While we can't yet detect gravitational waves from WOH G64 directly, theoretical calculations suggest that the star's chaotic mass ejections should be creating a constant stream of these space-time distortions. If this is true, then WOH G64 isn't just poisoning its local environment with radiation and high-energy particles, it's actually warping reality itself. The star has become so massive and so unstable that its very existence is causing the universe to vibrate like a struck bell. This raises terrifying questions about what happens to the laws of physics when matter reaches such extreme states. The chemical composition of WOH G64's expelled material tells an equally disturbing story. Spectroscopic analysis has revealed the presence of isotopes that shouldn't exist in a normal stellar environment. These exotic isotopes are typically only created in the most violent nuclear reactions, the kind that happen during supernova explosions or neutron star collisions. The fact that WOH G64 is producing these isotopes while it's still technically alive suggests that nuclear processes inside the star have gone completely haywire. The normal fusion reactions that power stars have been replaced by something far more chaotic and unpredictable. It's as if the star's core has become a nuclear free-for-all, where any reaction that's physically possible is actually happening. This nuclear chaos is also producing neutrinos in quantities that boggle the mind. Neutrinos are ghostly particles that barely interact with normal matter, streaming through planets and stars as if they weren't even there. But WOH G64 is producing so many neutrinos that if we had sensitive enough detectors, we could probably measure them here on Earth despite the star being in another galaxy. These neutrinos carry information about the nuclear reactions happening in WOH G64's core, providing a direct window into the star's internal processes. What they're telling us is absolutely terrifying. The neutrino flux from WOH G64 is orders of magnitude higher than what any theoretical model predicts for a star in this evolutionary phase. Something inside that stellar monster is creating nuclear reactions that we didn't even know were possible. The timeline for WOH G64's final explosion has become increasingly uncertain as new data continues to pour in. Initially, astronomers thought they had hundreds of thousands of years to study this star before it went supernova. Then observations suggested it might explode within a few thousand years. Now, some researchers are beginning to wonder if WOH G64 could detonate essentially without warning. The problem is that yellow hypergiants like WOH G64 has become are fundamentally unpredictable. Unlike other types of stars that follow relatively well-understood evolutionary pathways, hypergiants exist in a state of constant instability. They can remain stable for thousands of years, or they can explode tomorrow. There's simply no way to know for certain. This uncertainty is driving a new generation of astronomical surveys designed specifically to monitor hypergiant stars for signs of impending explosion. Telescopes around the world are now keeping constant watch on WOH G64 and other similar objects, looking for any change that might herald the beginning of the end. But even with all this monitoring, we might not get much warning. Computer simulations suggest that when a hypergiant finally collapses, the process happens so quickly that there's only a few hours between the initial core collapse and the moment when the explosion becomes visible from the surface. By the time we see WOH G64 starting to brighten, the supernova will already be well underway. The energy released from such an explosion would be so intense that it would briefly outshine the entire Large Magellanic Cloud galaxy. For several weeks, WOH G64's supernova would be one of the brightest objects in our night sky, easily visible even from light-polluted cities. Ancient civilizations would have interpreted such an event as a sign of divine intervention or cosmic catastrophe, and they wouldn't have been entirely wrong. A supernova from WOH G64 would pump enough energy into the Large Magellanic Cloud to trigger a burst of star formation that could last for millions of years. The shockwave from the explosion would compress gas clouds throughout the galaxy, causing them to collapse and form new stars at rates far above normal. This process of triggered star formation means that WOH G64's death could literally reshape an entire galaxy. The star's final explosion would create a cascade effect, with new stars forming in waves radiating outward from the supernova site. Some of these new stars would themselves be massive enough to eventually explode as supernovae, creating secondary waves of star formation. The heavy elements created in WOH G64's core during its lifetime would be scattered across thousands of light-years of space by the supernova explosion. These elements, carbon, oxygen, silicon, iron, and dozens of others, are essential ingredients for rocky planets and life as we know it. In death, WOH G64 would seed an entire region of the galaxy with the raw materials needed to build new worlds. But the story doesn't end with the explosion. After WOH G64 detonates, what's left of its core will continue to collapse under its own gravity. Given the star's initial mass of at least 25 times our Sun, this collapse won't stop at the neutron star stage. Instead, it will continue until it forms a black hole, a region of space-time so warped that nothing, not even light, can escape. This black hole won't be just any ordinary black hole. It will be a stellar mass monster with at least 20 times the mass of our Sun, spinning rapidly and surrounded by the superhot debris from the supernova explosion. As material from the explosion falls back onto the newly formed black hole, it will create an accretion disk that glows with the intensity of millions of suns. The black hole left behind by WOH G64 could remain active for millions of years, gradually consuming the material ejected by its own supernova. This creates a feedback loop, where the star's death continues to power energetic phenomena long after the initial explosion has faded. Radio telescopes might be able to detect emissions from this system for geological ages. Recent observations have also revealed something deeply unsettling about WOH G64's companion star. This smaller stellar partner, initially thought to be a passive bystander in the giant's death throes, is actually playing a much more sinister role in the unfolding cosmic drama. High-resolution spectroscopy has shown that the companion is not just stripping material from WOH G64, it's actively destabilizing the giant's internal structure. The gravitational interaction between these two stars creates tidal forces that penetrate deep into WOH G64's interior. These tidal forces are literally squeezing and stretching the giant star's core, disrupting the normal convective patterns that regulate nuclear fusion. It's like having someone constantly shake a nuclear reactor while it's trying to maintain a controlled reaction. This tidal disruption might explain why WOH G64 has become so unpredictable in recent years. The companion star's orbit is slowly decaying, bringing it closer to the giant and increasing the strength of these disruptive tidal forces. As the two stars spiral closer together, WOH G64's internal chaos will only intensify, potentially triggering the final collapse much sooner than it would occur naturally. The companion star itself is also being dramatically affected by this cosmic dance of destruction. Detailed analysis of its spectrum reveals that it's accreting massive amounts of material from WOH G64's stellar wind. This accretion is causing the companion to brighten and heat up, transforming it from a relatively normal star into something much more exotic and unstable. Some models suggest that by the time WOH G64 finally explodes, its companion might have evolved into a Wolf-Rayet star, an extremely hot, luminous object that's also nearing the end of its own evolutionary journey. This raises the terrifying possibility that we might witness not one, but two supernova explosions from this system, separated by perhaps only a few thousand years. The thought of a double supernova system is almost too horrifying to contemplate. The combined energy release would dwarf even the most powerful single supernova, creating a cosmic catastrophe that could affect star formation patterns across multiple galaxies. The gravitational waves generated by such an event would be detectable by our most sensitive instruments, providing a front row seat to one of the most violent processes in the universe. But even setting aside the possibility of a double supernova, WOH G64 by itself represents a level of cosmic violence that challenges our understanding of what's physically possible. This single star is simultaneously demonstrating nuclear physics at its most extreme. Gravitational effects that warp space-time, magnetic fields that accelerate particles to near light speed, and thermodynamic processes that create temperatures found nowhere else in the universe. Every photon of light that reaches us from WOH G64 carries information about physical processes that push the absolute limits of what matter can endure. The star has become a natural laboratory for testing the fundamental laws of physics under conditions that we could never recreate artificially. It's showing us what happens when every force in nature is pushed to its breaking point simultaneously. And that's perhaps the most unsettling realization of all. WOH G64 isn't just a dying star. It's a glimpse into the absolute extremes of physical reality. It's showing us what the universe is capable of when all restraints are removed, when the normal rules that govern stellar behavior are completely abandoned. This cosmic monster has become a window into the heart of chaos itself, revealing processes so violent and extreme that they seem to belong more in the realm of science fiction than scientific fact. Yet there it sits in the Large Magellanic Cloud, a very real reminder that the universe contains forces and phenomena that dwarf anything in our earthly experience. As we continue to study WOH G64, each new observation seems to raise more questions than it answers. The star has become a cosmic riddle wrapped in an enigma, challenging everything we thought we knew about how matter behaves under extreme conditions. And somewhere in that writhing mass of superheated plasma and twisted magnetic fields, the seeds of one of the most spectacular explosions in the universe are quietly taking root. The countdown to cosmic destruction has begun, and WOH G64 is the clock. But here's where WOH G64's story takes a turn that's genuinely keeping astronomers awake at night. The recent observations haven't just shown us a dying star, they've revealed something that fundamentally breaks our understanding of stellar physics. When scientists analyzed the latest data from the Very Large Telescope Interferometer, they discovered that WOH G64 isn't following any of the established rules for how massive stars are supposed to behave. The star's luminosity has been fluctuating in patterns that shouldn't be possible. Most dying giants show predictable brightness variations as they pulsate like cosmic hearts. But WOH G64's light output is dancing to a rhythm that defies every computer model we've built. 1 month, it dims by factors that would indicate massive structural changes. then suddenly it blazes brighter than it has in decades, as if something inside the star just ignited a new nuclear furnace. These brightness variations aren't just academic curiosities. They're symptoms of something deeply wrong with the star's internal architecture. When a star's luminosity changes this dramatically and unpredictably, it means the delicate balance between gravity trying to crush the star and radiation pressure trying to blow it apart has completely broken down. WOH G64 has entered a state of stellar anarchy where the normal laws of physics seem to have been suspended. What makes this even more disturbing is the speed at which these changes are occurring. Stellar evolution is supposed to happen over millions of years, not decades. Yet we're watching WOH G64 transform before our eyes like a cosmic time-lapse video. The star that astronomers studied in the 1990s is fundamentally different from the monster we're observing today. It's as if someone hit the fast-forward button on stellar death. The chemical signatures coming from WOH G64's surface tell an equally terrifying story. Spectroscopic analysis has revealed the presence of elements that have no business existing in a star's atmosphere. We're seeing isotopes of technetium, an element so unstable that it doesn't occur naturally on Earth. The only way these isotopes can exist is if they're being continuously created by nuclear reactions happening right at the star's surface. This means that WOH G64 isn't just burning fuel in its core like normal stars. Something has gone so catastrophically wrong with its internal structure that nuclear fusion is now happening throughout the star's outer layers. It's like discovering that a campfire has somehow spread to burn the entire forest from the inside out, consuming everything in its path with no way to stop the process. The temperature profiles across different regions of WOH G64's atmosphere are equally bizarre. While most of the star glows at temperatures around 3,000 degrees, certain areas are spiking to over 15,000 degrees, hot enough to ionize almost any element. These temperature spikes appear and disappear seemingly at random, creating a patchwork of thermal chaos that resembles nothing so much as a stellar fever dream. But perhaps the most chilling discovery is what's happening to the space around WOH G64. The star's violent mass ejections aren't just creating that egg-shaped dust cocoon. They're actually warping the structure of the interstellar medium for light years in every direction. The sheer amount of energy being pumped into the surrounding space is so immense that it's creating shockwaves that travel faster than sound through the thin gas between stars. These shockwaves are compressing and heating the interstellar medium to temperatures of millions of degrees, creating vast bubbles of superhot gas that glow with X-ray radiation. WOH G64 has essentially turned its entire neighborhood into a cosmic blast furnace, sterilizing space for dozens of light years in every direction. Any planets or smaller objects that might have existed in this region have been completely vaporized by the intense radiation. The magnetic field structure around WOH G64 has also evolved into something that defies conventional understanding. Most stars have relatively simple magnetic fields that can be mapped and predicted using standard physics. But WOH G64's magnetic field has become so complex and chaotic that it resembles a three-dimensional maze of energy that's constantly reconfiguring itself. This magnetic chaos is accelerating charged particles to velocities approaching the speed of light, creating streams of cosmic rays that radiate outward from the star in all directions. These particles carry so much energy that when they eventually collide with other matter in space, they trigger nuclear reactions that create entirely new elements. WOH G64 has become a cosmic particle accelerator that's actively changing the chemical composition of its entire galactic neighborhood. The gravitational effects of WOH G64's rapid mass loss are creating their own set of problems. As the star sheds material, its gravitational field weakens, but not uniformly. different parts of the star are losing mass at different rates, creating gravitational anomalies that are pulling the remaining stellar material into increasingly unstable configurations. This uneven mass loss is causing the star's rotation to speed up in some regions, while slowing down in others, creating internal shear forces that are literally tearing the star apart from within. It's like watching a spinning top that's simultaneously melting and being pulled in different directions by invisible strings. The end result is a stellar structure that's becoming increasingly chaotic and unpredictable. Recent models suggest that WOH G64 might be approaching what physicists call a hydrodynamic instability cascade, a point where the star's internal turbulence becomes so intense that it triggers a chain reaction of increasingly violent processes. Once this cascade begins, there's no theoretical mechanism that could stop it short of complete stellar destruction. The timeline for this cascade is impossible to predict with any certainty. It could begin tomorrow, or it might not start for another 1,000 years. But once it starts, computer simulations suggest that WOH G64 would have less than a year before it explodes as a supernova. The star would essentially tear itself apart in a frenzy of hydrodynamic violence that would make a nuclear weapon look like a firecracker. What's particularly unnerving is that WOH G64's companion star is showing signs that it's being affected by these instabilities as well. The smaller star's spectrum has begun showing emission lines that indicate it's being bombarded by high-energy radiation and particles from its giant partner. This bombardment is heating the companion's surface and disrupting its own internal structure. Some researchers are beginning to wonder if the companion star might be pushed over the edge into its own catastrophic instability. If both stars in this binary system become unstable simultaneously, the result could be a double supernova, an event so violent that it would briefly outshine the combined light of 1 billion normal stars. The neutrino emissions from WOH G64 have also reached levels that are forcing scientists to reconsider fundamental aspects of stellar physics. Neutrinos are produced by nuclear reactions and usually stream out of stars without interacting with anything. But WOH G64 is producing so many neutrinos that they're actually beginning to affect the star's energy balance. This neutrino flux is carrying away energy at rates that exceed what the star can produce through normal nuclear fusion. The only way this is possible is if exotic nuclear processes are occurring inside WOH G64, reactions that we've never observed before and don't fully understand. The star has become a natural laboratory for nuclear physics that's operating beyond the boundaries of our current knowledge. The dust composition in WOH G64's cocoon is telling its own disturbing story. Analysis of the infrared signatures from different regions of the cocoon reveals the presence of complex organic molecules, carbon-based compounds that form the building blocks of life. But these molecules are being created in an environment so hostile that they're simultaneously being destroyed almost as quickly as they form. It's a cosmic paradox. WOH G64 is creating the chemical ingredients necessary for life while simultaneously creating conditions that would instantly sterilize any living thing. The star is both a creator and destroyer of biological potential, producing and annihilating the molecular foundations of existence in an endless cycle of cosmic irony. The polarization patterns in the light coming from WOH G64's dust cocoon reveal another layer of complexity that's baffling astronomers. The way light becomes polarized as it passes through dust clouds can tell us about the structure and alignment of the dust grains. But the polarization from WOH G64's cocoon is changing on timescales of weeks, indicating that the entire dust structure is constantly reorganizing itself. This rapid restructuring suggests that the forces acting within the cocoon are incredibly dynamic and violent. The dust grains are being constantly accelerated, heated, cooled, and realigned by magnetic fields and radiation pressure in patterns that change faster than we can map them. The cocoon isn't a static shell of expelled material. It's a churning, evolving storm of particles that's as chaotic as the star that created it. The radio emissions from WOH G64 have also become increasingly erratic and powerful. The star is now one of the strongest radio sources in the Large Magellanic Cloud, broadcasting across multiple frequencies simultaneously. These radio signals are generated by electrons spiraling through magnetic fields at nearly the speed of light, creating a cosmic radio station that's audible across intergalactic distances. But the most unsettling aspect of these radio emissions is their variability. The signals fade in and out, seemingly at random, sometimes disappearing completely for days or weeks, before suddenly returning at intensities that exceed anything previously recorded. It's as if WOH G64 is trying to communicate something, broadcasting a message of stellar distress that we can detect but cannot decode. The X-ray emissions from the WOH G64 system paint an equally disturbing picture. High-energy telescopes have detected X-ray flares from the star that release more energy in a few hours than our Sun produces in an entire year. These flares are generated by magnetic field reconnection events, essentially stellar earthquakes that release tremendous amounts of stored magnetic energy in violent bursts. The frequency of these X-ray flares has been increasing over the past decade, suggesting that WOH G64's magnetic field is becoming increasingly unstable. Each flare represents a catastrophic release of energy that would sterilize any planetary system within dozens of light years. The star has become a cosmic weapon that's randomly firing bursts of lethal radiation into the void. Perhaps most disturbing of all is what's happening to time itself near WOH G64. Einstein's theory of general relativity predicts that extremely massive objects warp spacetime, causing time to flow differently in their vicinity. The rapid mass changes occurring in WOH G64 are creating temporal distortions that are actually measurable from Earth. Light from different parts of the star's surface is experiencing slightly different amounts of gravitational time dilation, causing the various emission lines in the star's spectrum to be shifted by tiny but detectable amounts. WOH G64 has become so massive and so dynamically active that it's literally bending the flow of time around itself. This temporal warping means that different regions of WOH G64 are aging at slightly different rates. Parts of the star closer to the core are experiencing time more slowly than the outer layers, creating a gradient of temporal flow that extends throughout the stellar structure. The star isn't just dying, it's dying at different rates simultaneously, creating a temporal paradox that challenges our understanding of causality itself. The implications of these discoveries extend far beyond just one star. WOH G64 has revealed that our models of stellar evolution are fundamentally incomplete. We've been studying stars for centuries, thinking we understood how they live and die. But this cosmic monster has shown us that we've barely scratched the surface of stellar physics. Every assumption we've made about how massive stars behave in their final stages has been called into question by WOH G64's bizarre behavior. The star is writing its own rules of physics, demonstrating processes that shouldn't be possible according to our current understanding of how matter and energy interact under extreme conditions. This revelation is both terrifying and exhilarating for the scientific community. Terrifying because it means our knowledge of the universe is far more limited than we thought. Exhilarating because WOH G64 is providing us with a front-row seat to physics that we've never seen before, offering insights into the fundamental nature of reality that could revolutionize our understanding of the cosmos. But as we continue to study this stellar aberration, one question looms larger than all others. What happens next? WOH G64 has already broken so many rules of stellar physics that predicting its future behavior has become essentially impossible. The star could explode tomorrow, or it might continue its chaotic dance of destruction for centuries to come. The only certainty is that when WOH G64 finally does reach its explosive end, the resulting supernova will be unlike anything we've ever witnessed. This won't be a textbook stellar explosion following predictable patterns. It will be the death of a star that has rewritten the laws of physics, and its final moments will likely reveal new aspects of reality that we never knew existed. The countdown continues, and somewhere in the depths of space, WOH G64 churns toward its inevitable and spectacular doom, carrying secrets about the nature of existence that it will reveal only in the moment of its ultimate destruction. The most recent breakthrough in our understanding of WOH G64 has revealed something so fundamentally disturbing that it's forcing astronomers to question whether we're witnessing the birth of an entirely new type of cosmic phenomenon. When researchers analyzed the latest spectroscopic data from multiple observatories simultaneously, they discovered that the star isn't just breaking the rules of stellar physics, it's creating its own rules as it goes. The atomic structure of the material being expelled from WOH G64 shows isotope ratios that simply shouldn't exist in nature. We're seeing elements with neutron to proton ratios that are so exotic they can only be created under conditions that exceed anything we've ever modeled. It's as if the star has somehow accessed nuclear physics that operates beyond our current understanding of how atoms can be constructed. What's particularly unnerving is that these exotic isotopes are being created continuously, not just during brief moments of nuclear chaos. This suggests that WOH G64 has established new equilibrium states within its core, stable nuclear configurations that weren't supposed to be possible according to everything we know about atomic physics. The star has essentially become a factory for manufacturing impossible matter. The energy signatures associated with these nuclear processes are equally baffling. When exotic isotopes decay, they should release energy in predictable patterns based on well-established nuclear physics. But the energy releases from WOH G64's core are showing signatures that don't match any known nuclear decay pathways. The star is somehow channeling nuclear energy through processes that exist outside our current theoretical framework. This discovery has prompted a complete re-evaluation of what we think we know about the limits of nuclear physics. For decades, scientists believed they had mapped out all the possible ways that atomic nuclei could be structured and how they would behave under extreme conditions. WOH G64 is proving that our nuclear physics textbooks are embarrassingly incomplete. The implications go far beyond just understanding one unusual star. If WOH G64 can create exotic nuclear processes, what does that mean for our understanding of other extreme environments in the universe? Are there other objects out there operating under nuclear physics that we've never encountered? The star has opened a door to realms of nuclear science that we didn't even know existed. The magnetic field interactions around WOH G64 have also evolved into something that defies conventional electromagnetic theory. Recent observations show that the star's magnetic field lines are somehow maintaining coherent structures across distances that should cause them to dissipate into chaos. It's as if the star has discovered a way to channel magnetic energy that ignores the normal rules of electromagnetic physics. These coherent magnetic structures are acting like cosmic transmission lines, carrying enormous amounts of energy from the star's core directly to its outer atmosphere. This bypass mechanism allows WOH G64 to transport energy in ways that shouldn't be possible, effectively short-circuiting the normal convective processes that regulate energy flow in other stars. The result is that different regions of WOH G64's atmosphere are receiving energy inputs that vary by factors of thousands, creating temperature gradients so extreme that they're generating plasma states that we've never observed before. Some regions of the star's surface are reaching temperatures that approach those found in the cores of other stars, while adjacent areas remain relatively cool. This temperature chaos is creating atmospheric dynamics that resemble nothing so much as a three-dimensional hurricane made of nuclear fire. Plasma streams are racing across the star's surface at velocities that exceed the escape velocity of most planets, creating shock waves that propagate through the stellar atmosphere like cosmic thunder. The acoustic properties of these shock waves are particularly disturbing. When astronomers analyze the frequency patterns of the oscillations within WOH G64's atmosphere, they discover that the star is essentially singing, producing acoustic resonances that span octaves of frequency. But this isn't a harmonious cosmic song. The frequency patterns are chaotic and dissonant, resembling nothing so much as the sound of reality itself screaming. These acoustic oscillations are so powerful that they're actually affecting the star's gravitational field. The rapid compression and rarefaction of stellar material is creating gravitational waves at audio frequencies, something that wasn't supposed to be possible according to general relativity. WOH G64 has somehow found a way to make gravity itself oscillate like a cosmic tuning fork. The detection of these low-frequency gravitational waves has opened up an entirely new field of gravitational astronomy. Instead of the brief chirps produced by colliding black holes or neutron stars, WOH G64 is generating continuous gravitational music that tells the story of its internal chaos in real time. We're not just seeing the star's death throes, we're hearing them through the fabric of space-time itself. But perhaps the most terrifying aspect of WOH G64's current state is what's happening to the fundamental constants of physics in its immediate vicinity. Precise measurements of spectral lines from the star show tiny but consistent shifts that suggest the fine structure constant, one of the most fundamental numbers in physics. Might this is true, it means that W actually be changing near the star. WOH G64 has become so extreme that it's actually altering the basic laws of physics in its local environment. The electromagnetic force, the strength of atomic bonds, even the speed of light itself might be different near this stellar monster than they are everywhere else in the universe. The star has created its own pocket dimension, where different physical laws apply. The implications of variable fundamental constants are so profound that most physicists refuse to even consider the possibility. If the basic laws of physics can change, then everything we think we know about reality becomes uncertain. WOH G64 might be showing us that the universe is far stranger and more mutable than we ever imagined. Recent observations have also revealed that WOH G64's companion star is undergoing its own bizarre transformation in response to its partner's chaos. The smaller star's spectrum now shows emission lines from elements that shouldn't exist in a normal stellar atmosphere. It's as if the companion is being infected by its partner's exotic physics, gradually transforming into something equally alien. This transformation is happening through mechanisms that we don't understand. High-energy particles and exotic radiation from WOH G64 are somehow reprogramming the nuclear processes within the companion star, causing it to begin producing the same impossible isotopes as its giant partner. The companion is essentially being converted into a smaller version of the cosmic aberration it orbits. The binary system has become a laboratory for studying how extreme physics can propagate from one object to another. WOH G64 isn't just breaking the rules of physics in isolation. It's spreading its reality-altering influence to other objects in its vicinity. The star has become a cosmic virus that infects everything it touches with impossible physics. This raises deeply unsettling questions about what happens when WOH G64 finally explodes. Will the supernova explosion carry these exotic physics processes with it as it expands outward? Could the shockwave from WOH G64's death somehow alter the physical laws throughout an entire region of the galaxy? The energy requirements for maintaining WOH G64's exotic processes are so enormous that they challenge our understanding of where this energy is coming from. The star is outputting more energy than it should be able to produce through any known nuclear fusion processes. It's as if WOH G64 has tapped into an energy source that exists outside conventional physics. Some theoretical physicists have proposed that the star might be somehow accessing zero-point energy, the quantum mechanical energy that exists even in empty space. Others suggest that WOH G64 might be channeling energy from higher dimensions through mechanisms we don't understand. The most exotic theories propose that the star has somehow learned to convert matter directly into energy at efficiencies that approach 100%. Regardless of the mechanism, WOH G64 has become an energy source that defies explanation. The star is producing power outputs that rival small quasars while maintaining a structure that shouldn't be stable under such extreme energy generation. It's a cosmic perpetual motion machine that seems to violate the fundamental laws of thermodynamics. The waste products from these exotic energy processes are equally puzzling. Instead of producing the expected byproducts of nuclear fusion, WOH G64 is generating particles and radiation that don't fit into any established categories. Detectors are recording particle signatures that resemble nothing in the standard model of particle physics. These exotic particles are streaming away from WOH G64 at velocities approaching the speed of light, carrying energy densities that would vaporize any conventional matter they encounter. The star has become a cosmic particle accelerator that's producing ammunition for a war against the known laws of physics. The trajectory calculations for these exotic particle streams show that they're following paths that don't obey normal gravitational dynamics. Instead of following predictable orbital mechanics, the particles are tracing complex spirals and loops that suggest they're being guided by forces we don't understand. G64 is somehow controlling the paths of its own emissions across interstellar distances. The interaction between these exotic particle streams and the surrounding interstellar medium is creating phenomena that resemble science fiction more than established astrophysics. Regions of space that are struck by WOH G64's particle emissions begin glowing with colors that don't correspond to any known atomic transitions. The star is painting its neighborhood with impossible light. These glowing regions persist for months or years after being struck by WOH G64's emissions, suggesting that the exotic particles are somehow altering the fundamental properties of the interstellar gas they encounter. The star isn't just ejecting material, it's terraforming space itself, converting normal matter into something equally exotic and incomprehensible. The communication implications of WOH G64's behavior have also begun to attract attention from researchers involved in the search for extraterrestrial intelligence. The star's emissions show patterns of modulation that are too complex and organized to be purely random. Some scientists are beginning to wonder if WOH G64's chaos might actually be a form of cosmic communication operating on principles we don't understand. The information density encoded in WOH G64's emission patterns exceeds anything produced by known natural processes. If these patterns are indeed carrying information, then the star is broadcasting more data per second than our entire internet infrastructure can handle. The cosmic significance of such a communication system would be staggering. But the most chilling possibility is that WOH G64's apparent messages aren't directed at us. They're instructions for other objects in space. Recent observations have shown that certain nearby stars are beginning to show subtle spectral changes that correlate with WOH G64's emission patterns. It's as if the giant star is somehow teaching other objects to replicate its exotic physics. This raises the terrifying possibility that WOH G64's influence is spreading throughout its region of the galaxy through mechanisms we don't understand. The star might be the epicenter of a transformation that could eventually affect countless other stellar objects, converting them into versions of its own impossible physics. The timeline for this cosmic infection is impossible to predict. The process could take millions of years to spread across significant distances, or it might accelerate exponentially as more objects become infected. We could be witnessing the beginning of a phase transition that transforms an entire region of the universe into something fundamentally different from everything else in existence. The philosophical implications of WOH G64's behavior are as disturbing as the physical ones. If a single star can rewrite the laws of physics in its vicinity, what does that say about the nature of reality itself? Are the physical laws we observe on Earth just local phenomena, no more universal than weather patterns? WOH G64 has forced us to confront the possibility that the universe is far more plastic and mutable than we ever imagined. The star suggests that what we consider to be fundamental constants might actually be variables that can be altered under sufficiently extreme conditions. Reality itself might be nothing more than a consensus that breaks down when pushed beyond certain limits. The psychological impact of these revelations on the scientific community has been profound. Researchers who have devoted their entire careers to understanding the fundamental laws of physics are now questioning whether those laws have any meaning at all. WOH G64 has become a cosmic existential crisis that challenges everything we thought we knew about the nature of existence. Yet despite the disturbing implications of WOH G64's behavior, the star continues to provide invaluable scientific data. Every observation reveals new aspects of physics that we never knew existed. The star has become humanity's most important natural laboratory, teaching us about realms of science that we could never access through conventional research. The technological implications of understanding WOH G64's exotic processes are staggering. If we could somehow harness the energy generation mechanisms that power the star, we could solve humanity's energy problems forever. If we could understand how the star alters fundamental constants, we might be able to develop technologies that operate under different physical laws. But accessing these technologies would require understanding physics that currently exists beyond our comprehension. WOH G64 is showing us glimpses of scientific principles that might take centuries or millennia for human civilization to fully grasp. The star is simultaneously our greatest teacher and our most humbling reminder of how little we truly understand about the universe. The ethical implications of studying WOH G64 are also becoming increasingly complex. If the star's influence is indeed spreading to other objects, should we be studying it at all? Are our observations somehow contributing to the propagation of its reality-altering effects? The possibility that our research might be accelerating a cosmic transformation raises profound questions about scientific responsibility. Some researchers have proposed that we should cease all observations of WOH G64 until we better understand the implications of its behavior. Others argue that studying the star is humanity's best hope for understanding and potentially controlling the cosmic transformation it represents. The debate reflects deeper questions about whether knowledge itself can be dangerous when it concerns phenomena that operate beyond conventional physics. The international coordination required to study WOH G64 has also created unprecedented challenges for the scientific community. The star's behavior changes so rapidly that observations must be coordinated across multiple time zones and wavelengths simultaneously. No single observatory or research group has the resources to monitor WOH G64 comprehensively. WOH G64 stands before us as more than just a dying star. It's a cosmic revelation that has shattered everything we thought we understood about the universe. This stellar monster has shown us that the laws of physics themselves might be nothing more than suggestions, breakable under sufficiently extreme conditions. As it continues its chaotic dance toward inevitable destruction, WOH G64 reminds us that we are cosmic toddlers trying to comprehend forces that dwarf our wildest imagination. The countdown to one of the universe's most spectacular explosions continues, and when that moment finally arrives, it will illuminate not just the night sky, but the terrifying depths of reality itself.